This is the lecture hitting the highlights for conditional probability. The difference is that, well, it's in the name. Conditional means the probability of something happening given conditional upon something else. And this is sort of most probabilities. You don't ask for the probability straight up. You usually say, what are the chances of this given something else happening? What are the chances of, say, a massive lava explosion given various earthquakes in Kilauea, right? So the notation for this is as follows. This is important because people make the following mistake. It reads the probability of A given B. It doesn't read A divided by B. It's really important. When people read this as division sign and put numbers inside, it screws them up. They get all the problems wrong. So make sure you get the notation down right first. It reads the probability of A given. That's what the slash means whenever it's within this PR notation, given B. Okay? Keep that in mind. So here's the first formula. The definition is the probability of A given B equals the probability of A and B, and then now since the slash is outside of the PR, this means divide. So divided by the probability of B. I have this emphasized here in the notation. Once again, whenever the slash occurs within the parentheses for PR, it reads given. Whenever it occurs outside, like here, it reads divide. I know that's confusing, but this is the book's terminology. So you just got to keep that in mind. The gambler's fallacy example can be read in the following way. I assume you guys have read this through, so I'm just going to hit the highlights. The coin example in particular, I want to talk about the diagram. So if you remember, you flip a coin. If it's heads, you draw from urn 1. There were 3 reds and 1 green, right? So the chances of getting a red are 3/4. And on the other side, if you toss the tails, you draw from urn 2. There was, by contrast, 1 red, 3 green, so the chances of getting a red are 1/4. Each of these branches represents the ways in which you can get 2 reds. You can draw from urn 1 and then get a red and a red. You replace them, you mix them up, and you draw again. And then, or you can draw from urn 2, you get a red and a red. And that's what the 2 branches represent, the purple and the blue. With conditional probability, we can ask a new question. Given that someone saw 2 reds, and suppose they don't know what urn is being drawn from, given that you just see 2 reds being drawn, what are the chances that you drew from urn 1? Now, if you think about it pre-theoretically, it should be that the chances that you're drawing from urn 1 are higher than the chances you're drawing from urn 2. Why? Because there are more reds in urn 1, and since you've drawn not just 1 but 2 reds, you think that the probability is higher that you're drawing from urn 1 as opposed to urn 2, just because, again, there's more reds in urn 1. So the more reds you would draw, say 3 reds, 4 reds, the higher the chances would be that you're drawing from urn 1 as opposed to urn 2. So the formula is probability of urn 1 given 2 reds equals, basically you put them together in the first part, probability of U1 and 2 reds, and then you divide by the right side over here. So probability of 2 R's. That's the general way to remember this. When you have this given that, the top part, the numerator, basically puts them together with and. So U1 and U and in this case 2 R's, and then the denominator, the thing on the bottom that you're dividing by, is the right side. So in this case, divided by probability of 2 R's. Yeah, and you can calculate that. I've got that already covered. And the lectures I have, this sort of calculations I have after that are basically going over this once again. The upshot is, here it is. So the idea is if you just saw 1 red, the chances that you're drawing from urn 1 are 75%. Why? Because there's 3 reds, so it's 3 out of 4. That makes intuitive sense. It should be 3/4. But if you get 2 reds, your probability increases in the chances you're drawing from urn 1. So the idea here is it moves up to 90%. The more reds you draw, that increases the chances you got them from urn 1. If you got 3 reds, that would be even higher than 90%, right? The upshot of diagrams and conditional probability. For For any conditional probability, you're going to have to diagram. This is crucial. This is why I'm not spending too much time hammering home the details of this lecture, because it's the practice that's coming up that's going to matter most. And we've got a bunch of problems to practice. It's really crucial that you do that to get acclimated to this. Your first exam is heavily weighted on this stuff. You first have to diagram, you then have to label the diagram, and then you have to know how to read the diagram, and then thirdly, translate that into a conditional probability formulation. The conditional probability formulation is actually just reading straight off of the diagram. So first things first, we're going to diagram, and then we're going to label it, and then we're going to ask the relevant probability question. Solving it is usually the last part, and relatively speaking, the easiest part. So for any conditional probability, the numerator, the thing on the top, will usually correspond to one branch on the tree. The denominator will be usually the total number of branches that give you the desired outcome. What do I mean by that? Let's go back to the diagram. So the conditional probability, after you do the diagram here, will correspond to this branch divided by that branch plus this lower branch. That's the way it usually will work. Okay? Once again, to emphasize that. Once you do the diagram, that's the first step. Then secondly, you do all the labeling. And then thirdly, you ask the probability question. What's the probability of getting 2 R's given that you got 2 R's, 2 reds, what's the probability that you're drawing from urn 1? When you do the formula, what that'll correspond with is this branch right here divided by that branch plus the lower branch. The two ways in which you can get 2 R's. And that's essentially what conditional probability amounts to in diagrammatic terms. All right, folks. Again, that was a lot, but let's start with the next lecture and the homeworks to start to hammer home what I'm talking about here. And with that practice, we'll get a feel for what this is about.